Hello and welcome to our lesson on prime factors. In this lesson, we'll focus on understanding what prime factors are and how to calculate them. Our lesson plan is as follows. First, we'll define prime factors and understand their significance in mathematics. Then, we will learn step-by-step methods to calculate the prime factors of a number. After ensuring a clear understanding, we'll run through some cases to apply this new knowledge practically. In our previous lessons, we've built a solid foundation by discussing factors, understanding what they are and how to find them; prime numbers, recognizing prime numbers and understanding their unique properties. With this foundation, we can now explore the concept of prime factors. This powerful technique is essential in various areas of mathematics, such as simplifying fractions, finding the highest common factor, and the least common multiple of numbers. This knowledge will thus enable you to solve problems more efficiently and understand deeper relationships between numbers. Let's get started. Let's look at defining and understanding prime factors. First, we must define prime factors. When we talk about factors of a number, we mean numbers that divide into it exactly without leaving a remainder. Prime factors are simply those factors which are prime numbers themselves. Remember, a prime number is a number greater than 1 that has no other factors besides 1 and itself. For example, consider the number 42. The factors of 42 include numbers like 1, 2, 3, 6, 7, 14, 21, and 42. Out of these, the prime factors are 2, 3, and 7 because they are the only ones which are prime numbers. Let's now consider the prime factorization theorem. The importance of prime factors is highlighted by the prime factorization theorem, which states, every integer greater than 1 can be written uniquely as a product of prime numbers up to the ordering of the factors. This theorem underpins much of number theory because it tells us that any number can be broken down into a unique set of prime factors, which is fundamental for various calculations in mathematics. Next is calculating prime factors. Let's go through the step-by-step process to find the prime factors of a number using 42 as an example. 1. Start with your number. Write the number you want to factorize on the right-hand side of a vertical line as shown on the right. 2. Divide by the smallest prime number. Check if the number is even. If it is, then 2 is one of its prime factors. 3. Divide and write the result. Divide 42 by 2 and write the result on the right-hand side. 4. Check for the next prime number. Now 21 is not even, so we check the next smallest prime number, which is 3. Determine if 3 is a factor of 21. It is, because 21 divided by 3 equals 7. 5. Continue until you reach a prime. Finally, we are left with 7, which is itself a prime number. We write it on the left-hand side and are done. So the prime factorization of 42 is 42 equals 2 times 3 times 7. Writing prime factorization in index form. Often we want to express the prime factorization in a more compact form using indices, also known as exponents. For instance, the number 12 can be factorized into primes as 2 times 2 times 3. In index form, this is written as 12 equals 2 to the power of 2 times 3. This form can simplify many mathematical operations by clearly showing the number of each prime factor present in the number. And there you have it, the prime factorization of a number step by step. Once comfortable with this technique, you can use it to simplify fractions, calculate GCDs, and solve a variety of mathematical problems more efficiently. Case study 1. Simple case with a small number. In our daily life, let's say you went shopping and bought 6 items. Now, to evenly divide these items, what are the different possibilities? Dividing into bundles of 1 and 6 and of 2 and 3. These are the factors of 6. To understand prime factors, we know prime numbers are numbers whose only factors are 1 and itself. For 6, they are 2 and 3. Consider a scenario where you are organizing chairs in rows for an event with 315 chairs. Trying to arrange them in rows might lead to the calculation of factors and prime factors. To find the prime factors of 315, first, divide it by the smallest prime number 2. Since 315 is not divisible by 2, try the next prime number 3. Second, 315 divided by 3 is 105. Then divide 105 by 3 again to get 35. Thirdly, since 35 is not divisible by 3, divide it by the next prime number 5 to get 7. And finally, since 7 is a prime number and divides evenly into itself, we stop here. Thus, the prime factors of 315 are 3, 3, 5, and 7. By calculating this, we know in advance all of our options for diving chairs into neat arrangements with no remainders. In today's lesson, we explored the concept of prime factors within the broader topic of factors, multiples, and primes. We began by defining prime factors as the prime numbers that divide a given number exactly without leaving a remainder. We stressed the significance of prime factors in mathematics, supported by the prime factorization theorem, which states that every integer greater than 1 can uniquely be expressed as a product of prime numbers. We then detailed a step-by-step method to calculate the prime factors of a number. This involved dividing the number by the smallest prime numbers sequentially until we reached a prime number. Additionally, we discussed expressing prime factorizations in index form to simplify mathematical operations. This understanding of prime factors is a crucial tool in your mathematical toolkit, enabling you to uncover deeper relationships between numbers and enhance your problem-solving skills. Watch the rest of the GCSE Maths course at Sophos Education.